Okay, so I think that actually the other one, it's saving it to my computer. I don't know why. So I'm gonna have to upload it at some point, the previous recording. So probably because of the crash. Anyway, so if we have a chocolate, like percentage is a great way of answering. Maybe like there are some areas actually that chocolate is not necessarily limited to being, brown color. We have white chocolate. We have, in some cases, what it's known as ruby chocolate. And you can actually see like ruby chocolate is this pinkish color. So we can leave, public string color. And so on, like as long as we're defining certain things that whatever we decide, if we decide to then now say we create a class and we say chocolate chip, and we decide to implement chocolate, the moment that we create a chocolate chip cookie implementing the chocolate interface, we're going to get some warnings. And the warnings are that we need to implement the methods. And the methods are percentage and color. So now here in the actual implementation, we're going from, let me actually put this guy here. We're going from this level down to this level when we are doing chocolate chip implements chocolate. So you can see that these methods, because they are in an actual class, they are now code complete. We are actually implementing those methods. But in the case of the chocolate, because those two had double percentage and double color, we are in the incomplete zone. We are not implementing anything. There's no return type, there's no body, there's no nothing. It's just right now we are declaring the definition of what are going to be the methods that interface should have. Now, if I were to ask a question, is chocolate chip instance of chocolate, what would be the answer?
It's like a instance of the interface.
It's like an instance of the interface. Is it yeah, but is it, if I were going to ask, is chocolate chip instance of chocolate? The answer would be true or false.
I'm not sure exactly.
Okay, let's see. Josh, what do you think?
I by the strict definition, I would say change my answer to false. No, false.
To false. Okay. Ali, what do you say? True or false?
False.
Okay. Well, let's see. Leon, what do you think?
Because I don't.
I think it would be false.
You think it would be false? George?
Because you.
Not sure, but probably false.
Okay. Jose?
Not sure, but false.
Okay. Sareth?
False too.
Okay, everybody's saying false. Well, so here's the news though. And this is where I wanted to take you, which is great. It's great that you're actually, I hate to say it, but all of you answered incorrectly, which is great because this is the way that we learn. Why would chocolate with a chocolate chip would be a chocolate? Well, the reason is because number one, there are concepts that are extremely abstract and they're not really concrete. And I don't mean to get in any way, I don't mean any disrespect to anybody or anything, but there are certain human constructs that are only human constructs. They are concepts in our minds. example, college degree. If we wanted to try to find out, I don't know, if, I don't know, let me say, Jose is a rocket scientist, or George is a chef, the only way that we would find out is by asking them, by actually looking at whatever credentials and maybe asking for some sort of proof. But by all means and purposes, you know, if you look at a person walking on the street, you cannot determine their profession. I mean, unless they're wearing the profession, that's, you know, a visual attribute. But you cannot, like, you know, if your neighbor next door was a doctor and you would never have crossed words with the doctor, I mean, with your neighbor, would you know that he's a doctor? Or he or she is a doctor? Not necessarily. Other human constructs religion, you know, like you cannot just physically determine if one person belongs to one religion or another. You know, there's plenty of those constructs that humans actually use. So if we, those constructs allow us, you know, well, let's leave those constructs for a second. Let's just think of, you know, if we were thinking about genetics, right? And we have a bear and we have a pig. And if we mix them, what would be the animal that would come out of that? Or let's say, you know, not maybe necessarily a bear, because let's say a lion. A lion and a pig. And the lion, you know, the method speak essentially returns roar. And the method speak for the pig returns oink, right? If we had a class, public class, that extended from both, what would the method speak would speak? Fortunately, you know, in the situation of genetics, you have a parent with blue eyes and a parent with green eyes or brown eyes. And, you know, nature is a toss-up. Basically, nature decides to toss a coin and the child has brown eyes. You know, in those situations, nature decides to flip a coin and get it. But in the situation of computers, computers need to be predictable. Computers need to be able to, whatever you do, there has to be a certain element of repetibility, including random numbers are not necessarily random. Sometimes they're derived as random from a seed and yada, yada. That's something to have a longer conversation about. But not everything in a computer, the goal is to make it predictable. So if we have two species that could be competing for a method, that creates a problem. The computer cannot just randomly choose, oh, for this instance, I'm going to return oink, and for this other instance, I'm going to return roar. Therefore, Java, to simplify that paradox, Java only allows inheritance or extension from one and only one object. We cannot do extends A, comma, B, comma, C. We only do extends parent class. That is to avoid this paradox. So far, so good. Let's give me some numbers about this part before I continue rambling on to other crazy stuff. Okay. So going back to human constructs, not everything the way that Java deals with unrestricting this thing is through the power of interfaces. Why? Because an interface is not going to collide. If you have 800 interfaces that have the method speak, none of them are implemented. Therefore, there's not going to be a collision. If anything, the class is going to be forced to have an implementation of that method. Now, if we decided that, for example, going back to human constructs, that we have, okay, so we can, from those constructs, we can start making very interesting corrections. Let's just say, for example, you know, as far as a profession, we also have the class vehicle, where, you know, we can inherit from that, and even we can say that well, let's say animal. So we can even say, you know, like a horse, that this is a class that we're extending from because it's very concrete. We can have an interface that defines a vehicle, and we have a profession that it's another interface. So if we wanted to create a horse doctor, we can actually, you know, and because the horse technically could be a vehicle, we can essentially use all these different concepts, where this is the class. Can you see my drawings, just by the way? Just want to make sure that you're able to see this.
Yes.
Okay. So from this perspective, we can do like some sort of crazy mechanisms to mix all these concepts. And the way that, if we wanted to, you know, essentially, because it's the same thing, it's not so unreasonable. We wanted to, like, you know, define what is a doctor. A doctor could be hours logged in you know, for your thesis and for your practice and whatnot. We can say that it has a degree. What other things could we say about a doctor? And here, I'm sorry, I'm not seeing the chat, so just speak up to those that have usually chat with me.
Specialty?
Specialty, yeah, perfect. Okay, vehicle, we know that, you know, we could have a move, because a vehicle moves. We can have a passenger capacity, or let's just put it capacity. We can have, you know, those are good enough. And then horse, everything, you know, the what's the what is it called, in the sound that a horse makes? I forgot. I need to go back to kindergarten.
Nay.
Hey, yeah.
Nay, okay. So so, you know, we have all the ingredients for like making something really ridiculous and essentially have some sort of multiple inheritance. Now, if the implementation of the doctor has a specialty, a degree, and an hours log, would that doctor be a doctor? Would that horse be a doctor?
Yes.
Yeah, exactly. So that answers, you know, let's just make a horse with a stethoscope, and dressed as a scientist type of thing. Yes, technically, yes. So that answers a question that we were saying. Is anything that, you know, is a chocolate chip cookie a chocolate? Well, technically it is, because it's implementing that. Now, how would we go about putting all these values in a single class? We say public class horse doctor, and extends, and we only can have one extends. So we say extends horse, implements, and here it doesn't matter how many we want to put. We can put implements doctor, comma, vehicle. Okay. And Zoom still hasn't started on the other computer. I have no clue why.
Could Juan, could we have extended doctor and implemented horse vehicle?
If, as long as this is a class, because remember that it's in the definition.
Okay.
Like if you look at the code that we had for chocolate, it doesn't say public class chocolate. It says public interface chocolate. Does that make sense?
Yeah. Yeah.
Okay, so let's get some numbers about the quote multiple inheritance interface, all that we've been talking about. Okay, so now you guys can see then this slide that it is the final keyword. So far we've been talking about how to extend the class, how to continue to add more stuff so that way we don't have to repeat ourselves, right? And that is cool and all, but what if we want to hit the brakes a little bit on what we are sharing, you know? The final keyword allows us to do that. Again, this is another example where I wish that the creators of Java would have chosen a different set of words, that they could have chosen a different naming, but okay, final, it is what it is. So that means that once it's final, you cannot modify it. And final can happen in three particular cases. Case number one, it is when we extend the class. That means that if we have that example where it says this guy here, let me put it in play. So this particular case is actually wrong because we cannot have final and extends. Actually, no, that's correct. That's correct. What means is that once we have the keyword final, we cannot say, we cannot subclass it. So we cannot say public, JC's cookie extends macaron. We cannot do that because this class has been marked as final, and final is essentially hitting the brakes on what we can extend or not. So far, so good. I'm gonna need like audio cues in here as opposed to visual cues.
Well, you mean if the class is defined as final, it cannot be used as the like object to inherit it?
Correct. That's exactly what I mean. That's exactly what I mean.
But only for inheritance? What about the other, like implement?
Yeah, so that is when we use it on final class. Sorry about all the technical difficulties, but we're making it through. We're gonna make it. So if we want to hit the brakes at the method level, we can say that a method is final, and you can inherit that class, but you will not be able to override that method.
Okay. What about use the method?
What about what? Oh no, you can use it. It's just that you cannot modify it. That means that you cannot extend it and override it. Okay. So that's why I'm calling it like hitting the brakes. The final keyword hits the brake on inheritance to modify a value that was already defined. And same thing applies for members like this, where we have like a method that says public, an attribute or an instance variable or member or whatever you want to call it. There's like 20 names. That once you are past this line, we will not be able to reassign a value, only upon creation. Again, the final keyword only allows us to not modify a value after it has been created. Therefore, we cannot extend a class that has been modified, that has been marked as final. We cannot extend or override a method that has been marked as final, or we cannot change a member that has been marked as final.
So we can't override that int folds, but if we wanted to use it, we couldn't change the value of folds.
Correct.
Yeah.
It's just a way of saying this is read only, and you cannot change it. So it's a mechanism of safety, you know, if you want to use it that way.
Juan, can you still instantiate the class, or can you not do that?
Yeah, no, you definitely can instantiate the class. You will not be able to extend the class. Meaning, if you want to, why are the common things why people actually extend a class? Well, let's go into the drawing board again. Let's assume that we have the class string. And if we wanted to, we could essentially extend from, we can call it, I don't know, Josh's string. And he could essentially extend, unless it was marked as final, which we'll check in a second. He could extend from string and start modifying by adding the method reverse. And also he could add the method, like override the way that, I don't know, uppercase is done. He could extend it, but there is a heavy debate about extending classes that you're not supposed to extend, because you could alter the functionality to the point that it's unusable, because technically Josh's string, when you do an instance of string, it will yield yes or true. So because it's going to say, yes, I am a string. I just happen to be the child of a string, therefore I am a string. Some people discourage inheritance. And there's a heavy debate, even in computer science, about if it is a good idea to even have object-oriented programming because of that. Because people are like, no, you're not supposed to be extending. So if I were to check like the Java string API, actually, let's do it in here. Java string app API. You can see that string is marked as final. You can see it right here, that the definition of string is marked as final. Therefore, we're not going to be able to extend it. Does that make sense? I would love to be able to get some numbers from you guys about this part.
I'll throw out a 9.
Okay.
Juan, I think in C#, it sounds like it's the same as the sealed keyword.
I would not be able to tell you because I have not touched C# in
Okay, never mind.
22 years or something like that.
Okay.
Since 2003, let's say, I have not touched C#. But yeah, there's ways of there's similar concepts, but yeah. Okay, so I only got from Josh and Leon 9s. Who else is or what are your guys' numbers?
I'm a 9.
Okay. It's just I can't. I'm on the iPad, so I'm kind of limited. Okay, so then let's see, Sareth, Jose,
9.
Ali.
I put it in the chat, but it's a 9 for me.
Okay, Sareth.
Yes, 9.
Let's talk about then the assignment for the homework. What we're going to do is that we're going to play a little bit with all these concepts, and basically there's a few examples of the classes in the assignment where we have a class called Polygon and an interface called Shape. The Polygon is just essentially a class that will represent, given the number of sides, it's going to have a constructor for the number of side lengths, meaning you can do like like the super constructor, we're going to call it, like if it's a triangle, you're going to call it super constructor with like a 3, or if it's a rectangle, you're going to call it with a super 4, because that's going to generate the number of sides. And then it has an abstract int side count, meaning that the classes, for example, if you're writing the rectangle, you're going to have to implement that method side count as returning 4. If you have a triangle, you're going to implement that method returning 3, and so on. What I would like you guys to do, and this is the assignment, is that, can I delete with this? Oh, this guy should what is this? That's a pointer only. Interesting. Never really use that. So what I would like you guys to do is, for that assignment, I need the triangle, rectangle, and circle implemented. Obviously, the circle is a shape, but it's not a polygon, because a polygon is essentially means many sides. A rectangle is a polygon. A triangle is a polygon, so the circle is not a polygon. So rectangle, triangle, and circle will inherit from shape, but circle will not inherit from polygon. I would like you guys to implement these 2 methods, because those are required by shape, and also any method that it's abstract, which is side count. So if you might have to do some Googling if you don't remember how to use how to calculate the perimeter of a rectangle. You might have to do some Googling to find out the perimeter of a circle, etc. But the idea is to use object-oriented programming to like solving these problems. Is there any questions about this assignment? So then I would say then that's basically then it for as far as a class.